Hi everyone, last Thursday on April 30th, you had a check going over two probability problems, number 2 and number 3. So I just wanted to break down the solution for those. So number 2 said, wanted you to find the probability of landing on the same color in both spinners. All right, so looking at my spinners, if I wanted to land in both colors, that means spinning red, red, a blue, blue, or a green, green. So let's find the probability of each of these events occurring. So to spin a red and then a red, that would be a 1/8 times 1/4, or 1 out of 32. Okay, to spin blue, blue, that would be 1/2 times 1/2, or 1/4 of the time you can expect to spin a blue, blue. And then finally to spin a green, green, that would be 3/8 times 1/4, or 3 out of 32. Now I'm going to combine these events occurring because I want the same color both times. So that would be 1 out of 32 plus this 1/4. I'm going to make it so I have a common denominator. So I'm going to multiply top and bottom by 8. So 8 out of 32 plus 3 out of 32. Okay, so then this becomes 8, 9, 10, 11, 12. So 12 out of 32, which I can divide both of those by 4. So 12 divided by 4 is 3. 32 divided by 4 is 8. So 3 out of 8 spins, I would land on the same color both times. Okay, so that one we broke it down without necessarily needing an area or a tree diagram, just with my work, but definitely an area model would have been really great to use for number 2, because you could have compared spinner 1 to spinner 2, right? So if I do spinner 1 here, I have 1/2 blue, 1/8 red, and 3/8 green. And then for spinner 1, spinner 2, I have 1/2 red, 1/4 green, 1/2 blue, and gridded it up into your 9 possibilities. And then we would be looking for the red, red, the green, green, and the blue, blue, right? And so we'd multiply to find those. So then we'd have our 1/4, our 1 out of 32, and our 3 out of 32. And then we can just total the same exact way. So definitely an area model for number 2. For number 3, and a lot of you said this, a tree diagram is the way to go, but I don't know how detailed you made your tree diagram. So I went through first and compared, okay, we had shoes. There was a total of 5 shoes that you could choose from. 2 pairs were black, 3 pairs were 5. So I have for black shoe, it'd be a 2 out of 5 possibility for that pair, and then for brown, 3 out of 5. For pant, you had 4 pairs of pants, 3 of which were black, 1 was brown. So for black pant, it would be 3/4. For brown, it'd be 1/4. And then finally for socks, this was probably the hardest part. There was 12 different pairs of socks, right? 6 of them were black. So that's why I simplified, okay, 6 out of 12 is just a 1/2 that no matter what pair, it's going to be black. 2 pairs were red, so 2 out of 12 was 1/6, and 4 of the pairs were brown, so 4 out of 12. Okay, so made my diagram. Then it said wanting to find the probability of all the items being the same color. So I mean black shoe, black pant, and a black sock, right? So going through there, okay, if I had a black shoe, black pant, black sock, that's 2/5, 3/4, and 1/2 to find this possibility here, right? So we'd have 2/5 times 3/4 times 1/2. So the probability of wearing a black shoe, a black pant, and a black sock, multiplying this, would be 2 times 3 times 1, which is 6. 5 times 4 is 20, times 2 is 40. So 6/40ths, which simplifies to 3 out of 20, okay? But remember, you also have the possibility that you could have all brown items, right? I'm gonna use this, I'll be starting here, so I could have a brown shoe, a brown pant, and brown socks, right? And that would be 3/5 times 1/4 times 1/3, which this becomes 3 times 1 times 1 is 3. 5 times 4 is 20, times 3 is 60. Can divide both by 3, so I have 3 out of 60, which this simplifies then to 1 out of, just kidding, 1 out of 20, okay? Now, I want the possibility of both these events occurring, so I'm going to add these two, the probability of wearing all black, probability of wearing all brown. So 3/20 plus 1/20 would be 4/20, or a 1 out of 5 that no matter what, all items would be the same color. I really hope that helps to clarify some of your issues. Thanks, Saints.